First thing that's happening that's different than yesterday is the kind of question will say, use the remainder theorem to evaluate. I'm just going to make something up, f of 4. And I'm going to use this equation down here, okay? Use the remainder theorem to evaluate f of 4. So when it says use remainder theorem, that is code for use synthetic division. And the remainder is your answer. Now, before, when we did evaluate, and it's still true, when you evaluate an equation like this, you would just put in 4 in the equation and figure it out. But synthetic is easier to do, and it's a quicker way to get to that same answer. So if you see it like this is what you're going to do. You're going to, like, since this says 4 right here, I'm going to put 4 in that sidebar, or side box. And then I'm going to list my coefficients in order. This will be 1, -3, 5, and -3, right? Okay. And if you remember with synthetic, we just take that first number, bring it straight down, multiply, add, becomes 1 times 4 is 4, 9 times 4 is 36, so that gives me 33. So my answer is the 33. So f of 4 equals 33. That's my answer. That's all it is. Kind of keeps you from getting into big numbers and technical sign errors and stuff like that. All right, so that's the first newish thing with 3.3b. Then it says use the rational zero test. Okay, so if you look above here, this is the rational zero test. This is what we used back in the day before we had graphing calculators, where we could graph our equation and see, literally see, where does it cross the x-axis. Back in the Stone Ages, we had to do it numerically, so this is what we had to do. And you just have to know what this is and how to use it, all right? You don't have to do all the things that we did, I promise. But you got to know what this means. So rational zero test means I'm going to take the factors of the constant term. Okay, do you know which number in the equation is the constant term? It's kind of important. The 3 on the end, yes. So if you don't know, the constant term is this -3. The leading coefficient is the coefficient with the highest power, right? So this is a 1. So in this example, my possible zeros, factors of the -3. Factors, remember, mean what are the numbers that you can multiply together to get -3? What numbers multiply to give you 3? Surely only 2. 1 and 3, right? With all the combinations of positives and negatives possible. So 1 and 3, now we would just put plus or minus on them because we don't know if it's -1 and a +3 or -3 and a +1. We don't know. But we can look at it. And then the denominator is the factors of the leading coefficient. Well, the leading coefficient in this equation is just a 1. So when it comes to listing these out, I'm going to do it longhand, but just to show you. All right, so what does that mean? That means I either have a positive or -1 or a positive or -3, right? Okay. So these are the possible zeros. So back in the day, before calculators, we would have to do synthetic division, try it with +1, try it with -1, try it with +3, try it with -3, until we get one that has no remainder. That's how you know if it's an actual zero. Now, for me, what you're going to do for me is list out the possible zeros, and then you're going to go to your calculator and find the one that works. Because there's no sense in doing all that extra stuff. And then you're going to prove it to me just using synthetic. All right, so if I put it in a calculator, let's split this over. Okay, I have it here in the equation for you already. And if I go to graph, look at where it crosses the x-axis. And look at all our potential answers here. Which one of our potential solutions is it actually using? Positive 1. Does everybody see that? Yeah? Yeah? So positive 1 is for sure a solution to this equation. So that's the one I'm going to do synthetic division with. All right? That's how you decide. So I'm going to do 1, and I'm going to put in my coefficients. I should end up with a 0 for remainder, since I've visually seen it is a solution to this thing. So there should be no remainder. So if I bring 1 down, 1 times 1 is 1, negative 2, 5 minus 2 is 3, 3 times 1 is 3, and there it is, 0, right? Okay, so we've confirmed it. This is your proof that it works. Now notice what it says. The directions say use synthetic division to completely factor. All right, so what we've found is that 1 is a solution. So one of my factors is x minus 1. Why is it minus 1 but not a plus 1? Because why? It's in factor form. It switches signs. Remember that? Okay. Now we're not quietly finished. We're not completely finished because it says completely factor. So what we've done is divide out 1x from this. This was x to the third, right? So what we've come up with is x squared minus 2x plus 3. And we need to completely factor this, get this all the way down to x equals something, so we can put it in factor form. All right, now, is this one gonna factor? It will? How's it gonna factor? If it was minus 3, it might, but it's not. No, I don't think it factors. So we're gonna use either quadratic formula or completing the square to finish this off. I know. It's gonna be fine. Let's complete the square. Okay, so I'm going to move my 3 over. Now I complete the square. I copy the variable, copy the sign, cut the value in half, and square it. So I have negative 3, and I have to take negative 1 and square it and add it to the right side, so that's going to be plus 1, right? So I have x minus 1 squared equals negative 2. Now we square root both sides, right? Plus or minus. Okay, negative 2 means I need to take an I out, right? Because it's negative under the radical. One little last step is I'm going to move that 1 over and it becomes positive. All right. So this is not a rational solution. In fact, you can't even see this on the graph. If you graph this, remember it only crossed the x-axis one place, right? So this is 2 imaginary solutions that you can't see. But we know it has to have them because x is to the third power. Now, how do I write that as a factor? All right, it's all dependent on the sign of this guy right here. That's the sign that's going to switch. So I would say, since it's a positive 1 there when it's solved, I'm going to make it minus 1, and you can write it for now as plus or minus I square roots of 2. And that would put it in completely factored form. You don't have to do that on every question. I don't think today. It is coming up, but it's not necessarily today's lesson.